Alright, day 47 of Codeforces every day until GM. Let's go. We're jumping into the ADC ladders today. So I think we'll just start with 1200, see how we're feeling. Supposedly these questions are like more modern questions. So for example, let's start with what's this saying? Remove 2 letters. This is Codeforces round 855. So like the ones we've been doing, they've been around like from round 1 to freaking round 500. Like some of these are newer ones, but like most of my questions are like very early questions. 855 is like right in the middle of the pack, I guess, but yeah, some of these questions like same differences. They're like uh 1520. Oh yeah, I didn't even look at this. This is 1800. So this is a quite fairly new question, right? But the idea is the ADC ladders the ratings will be more accurate or more up to date to like current contest questions. Speaking of contests, I need to do another contest soon. It's been a little while, but yeah, let's just jump straight into it. Let's see where we're at with 1200. If we're breezing through them, which I don't breeze through 1200 normally either way. We'll move on to 1300, but yeah, let's just jump straight into it. Remove 2 letters. It's a problem D, which is quite interesting. I have not done a lot of problem Ds, but it's a low rated problem D. Usually problem Ds go for like 1500, right? So this is like quite lower rated than expected, or somebody probably just found an easy way to solve it or some workaround. Okay. Has a string consisting of lowercase Latin letters, decides to move 2 consecutive characters from string S, and you're wondering how many different strings can be obtained after such an operation. A, B, C, C, you can get the following. Okay. Wait, so remove 2 consecutive characters. How many different strings can be obtained after an operation? Okay, so there's probably some math answer to this. Alright. So, first input equals t equals int input. For the test cases, first line for underscore in range t, we get in equals int input, and then we get s equals input. So that should be our input, and then output for each test case print one integer, the number of distinct strings that can be obtained by removing 2 consecutive letters. So time limit per test 2 seconds, memory 2 times 10 to the 5. So probably not in okay. Print 1 integer, the number of distinct strings that can be obtained by removing 2. Okay. So A, B, C, C, you can get this, this, this. Okay, yeah. So for a length of 6, we can get 4. Well, it really depends on. It depends on the length. It depends on the copy or the number of like copies, right? Because 6. Hold on, I need to turn off my dark reader. It doesn't even match up for me, so it doesn't matter. Let's turn this back on. 6, 4, 10, 6, 6, 5. A, B, C, D, E, F. So we start off with like if all, what the hell? If all different, like, then it's just n minus 1. So I guess next we can look at this case here. Or like A, B. If we remove 2, remove 2. Like removing these two are basically the same, so that's 1. Then remove these 2, and that's another 1. Now, what if AAB? Remove these 2, remove these 2. So, still doesn't matter. So, it's still n minus 1, right? 2. So it becomes, okay, it's saying this is a data structure's greedy hashing problem. How I'm looking at it is, actually I'm not too sure how I'm looking at it. I need to look at this case, CCCFFF. This is, removing these would be the same. Removing these would be the same. So it'd be n minus 1, so 5. Then minus 1, 3. CCCFFF. So this is 1, 2, 4, 5. 1, 2, 3, 4, 5. Okay. So A, B, B, A should be just n minus 1, which is 3. And A, B, A, B, A. Moving these. Oh, so this is the other case where it makes it not as simple as if we think, right? If we move this, we get A, B, B, A. If we move this, we get the same. If we move this or this, we just all get the same. So it's still A, B. So I'm thinking we just try. Like we have a counter to print equals 0. And then we have a set. We should turn S into a list. And then strings equals set. Then for I in range n, start from 1, go to n. string stir what should I call it? Subster equals s from I minus 1, or from 0 to I minus 1. Well, this is it. Plus si to the end. Well, that isn't exactly what I wanted to do. Let's just remove this for now. A, B, C, D. Huh? We start with nothing. We start with B, C, D, E, F. Not exactly what I want. 1. C, D, E, F, and then A, D, E, F, and then A, B, E, F, A, B, C, F, A, B, C, D. Okay, yeah, this is right. And then for each one, if subster not in strings to print plus equals 1 string add subster, and then at the end we'll just print to print. Okay, subster unhashable type list. Wait, do I have to make it a list? There we go. That wasn't too bad. This is problem D. Knowing me, I'll like miss a case, or miss some edge case or something. Memory limit exceeded. Wow. Just can't give it to me first try, huh? Jesus. We are checking every single. Like, oh, Vanna's not fast enough? Really? Uh. Hmm. We need to go back to playing with cases. So I think this case is like the most important case here. Because, okay, we know n minus 1. But whenever there's these duplicates, it becomes. Okay, I want to check CCCCFFF. So n minus 1 is 6. And this is what? This is same, this is same, this is same. So this is minus 2. And this is minus 1. So it should be 6, 5, 4, 3. So if I try something like 1, 6, 1, 7, CCCF, CFFF, this should be 3. Yeah? So, uh, hmm. I just don't know how to deal with A, B. A, B, A. Like, this case is very important, I feel like. N minus 1. Okay, so this and this are like something different, right? We only get the same string when it's a copy of at least 3. So SI, if SI equals SI plus 2, then we'll have a copy. So this feels like a total minus like observed like 2 nights from CSES, where we have a total minus overlap type question. Well, oh yeah, because this is cool. This actually works for this too. But if like A B B A B A, then this is a new string. This is new string. This is a new string. And these repeated. Yeah. So basically, if this, then we subtract it from n minus 1. Or like we count these. Like we count the number of times this happens, and then we subtract that from n minus 1. So we actually end up printing something like n minus 1 minus overlap. And then what do we need? Probably just reset all this. We have to find a overlap equals 0 for I in range. We start at 2 because we can change this to I minus 2 and then S2. So we start at 2, stop at n, and then if Si minus 2 equals Si, overlap plus equals 1. Something like this. Loki works. And this doesn't run into the memory constraint because we don't have to deal with the set, right? Not missing anything. Like this seems really easy for a problem D. Like I feel like normally for problem D I would have got stuck for like 30 minutes. This was like a pretty fast solve, 24 minutes. Let's try it first to make sure we don't run into any other answers. But like it's like once you like see something like this, it just feels like the right answer, you know what I mean? Like I was actually like at first thinking lead code two sum for this question, but like this is really interesting. It's like for the past few questions, if you can find a math way to do it, it's really good. Like it feels like the last few questions have just been like math. But I guess this wasn't really math. This was like more like realization. It was just realizing that in this index and index I and I plus 2, if they're the same, then you'll have duplicates. Very interesting. I wonder, how would I realize this from just seeing the question? I don't know. I feel like you just need to play with test cases until you see it. That's basically what we did. But like, I don't know. I feel like if you looked the wrong way, you would totally miss that, and it would take up like half your time. Okay, sorting game. So you look at the diaspora. This one is A and it's 1200. This one's D and it's 1200. This one felt a little easy. Like, yeah, I'll give this one like a valid 1200, maybe 1100. We'll see this one. I play a game on a binary string S consisting 0 and 1s. Okay, I've heard this before. In one turn, chooses a sequence such that form a non-increasing sequence. Okay. Player then rearranges to be sorted in non-decreasing order. Let the chosen characters consist of Z0s and O1s, where equals M. The move replaces with the sequence of zeros followed by O1s. Strictly modifies the string. A player who cannot make a valid move loses. Assume both players play optimally. Determine the winner. If Alice wins, output a valid first move. Okay, so let's take in some input first. What do we need? All this still the same. Okay, all of this is still the same. Like this. Okay, output is one of 3 lines. Bob wins, print Bob, Alice. Otherwise, print 3 lines. Alice, integer, an integer M, indices for first move. Okay, M was O plus Z. So, first case, no way to make a move after which S will change, so Bob wins. Third example, 1 and 2, and sort it after that. We'll turn it into 011, and Bob can't make a move, so Alice wins. Okay, so what is the game? One person chooses a sequence of indices such that the characters form a non-increasing sequence. So your chosen thing has to be decreasing. Wait. Of indices such that the characters at these positions form a non-increasing sequence, that is. Rearranges to be non-decreasing. M. M is zeros plus ones. Why is M2 here? Sequence sorted. Indistinct integers. I'm genuinely confused. So, oh, wait, so they're saying you select 1 and 2. So they're selecting 0 and 1 and sort it. Okay. And then you print out 1 and 2. So M is just the length of the substring. And then you print out from 1 to N, or M. Or what? Okay. Let's think about this now. The thing is, I don't even know really where to start to think about this problem. You given a string. Oh, they have to be decreasing. It's like 1, 1, 1, 1. All the ones in the front, and then O's in the back. And then what? Uh, okay, when does someone win? I guess we can have like a sorted S equals S dot sort. And then something like if S equals sorted S print someone. Turn. We need a turn tracker. Who goes first? Assuming Alice. Okay. Now, so what does our inputs like actually look like? Like we can have all the same, right? Then these are insta-bob wins. Technically, we want to print out Bob, because this is it's Alice's turn, so we print Alice. We print who wins, right? So we print Bob. Okay, and well, we can just do like it makes it a little bit confusing, but it's more simulatey. And then we print and print. What do we print? We print M. M is the length of a thing, and then print M. And then we print some range. I don't know. Let's not define this just yet. Figure it out. So, what cases do we have? Like alternating case, like 10101. We have cases where it's wide case. And then maybe something like this. So like this, we would probably choose. Well, what do we actually want to do? Forming non. Uh, I don't really get this game. I'm thinking about it. Okay, basically, do we need this? It's okay. If it's sorted by default, Bob wins. And then we just exit, or break in this case. And then we can move this down, like this. Because Bob only wins when they're like this. Because Alice can always... Like, what's stopping her from just choosing the entire array? Form a non-increasing sequence. A non-increasing sequence. To be non-decreasing. So it's non-decreasing is just another word for increasing. A non-increase chooses a sequence of indices such that the characters at these positions form a decreasing sequence. The characters at these positions form a decreasing sequence. Players reorders them to be increasing. So is this even right? Is there other ways for Bob to win? So what we can do is sort all these. But dude, this question is... I can't understand the wording to this question. Mm. The sequence of indices. My non-increasing sequence. So they're decreasing. Does it have to be like in order? 1, 2, 3, 4. Like if it doesn't have to be in order, we can literally just pick like this, and then right. Like this part would make more sense. So then all the ones will be in the front, and then all the zeros will be after. And then you basically reverse that. And then what? Am I always picking a block like this? Or is it ever like this? Over here. I pick all of these, right? I pick all of these. I pick all of these. So here's what I'm thinking. It seems to me that Alice can always win. Basically. Actually, I wonder about. No, 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 no. Alice can always win. Yeah, Alice can always win. Unless it's sorted by default. So yeah, my initial intuition was correct. But the idea is we always choose. Okay, I don't understand why they want to do it like this. They want to print the distinct integers, the indices chosen for first move. So it's always going to be like a range of like from A to B, every number in between. And also to find that number, basically what we do is we check for the first and last like difference. So it's 2 pointers. We start from the beginning of the sorted and then the end of the sorter, and we check if same. No, then we log this next 0. It is same, so we move on. It's different, so we log this 0, 1, 2, 3, 4, and then this is our index range to reverse on this basically, and we basically range L R, and that's what we print out. So okay, I think I got it. So wow. Okay, left equals 0 while S L equal to sorted S L L plus equals 1. So basically just checking these are equal, move to the next. If these are equal, move to the next. So basically just checking the zeros. Equal, move next. Equal, move next. Equal, no. So we don't go through here. Now we start from the right side, do the same. Equals, and so 1, 2, 3, 4, 5, 6 minus 1. If R minus equals 1, now we print R minus L, then range R from left to right. No output. Great. String has. Oh, I need to. Like this. Index out of range. Well, SL equals sorted L. Index out of range. How am I getting... Oh, if they're all the same? Huh? It should never be the complete same. Why did nothing print at all, by the way? Shouldn't I have gotten something? Okay, why is this not running? Why did it not go in here? What the hell? Just turn S into a list. Why does it end here? Oh, it's not break, it's continue. Do we need to unpack this? No, wait. I'm confused. L is 0, R is n minus 1, which is 1, or 2. 2 minus 0, 0, 1, 2. 1. 1 minus 0 is 1. Plus 1. From 0 to R plus 1. Unpack it. It's like R plus 2, L plus 1, something like this. Okay, but I need to check for my cases. 1, 2, 3, 4, 5, 6. 6 cases. 4, 4, 4, 5, 5, 5, 4, 5, 5, 6, 8. 4. Bob, Bob, Alice. 4, 1, 2, 3, 4. Alice, 4, 1, 2, 3, 4. Alice, 5, 1, 2, 3, 4, 5. And then Alice, 5, 0, 1. It's 1, 2, 3, 4, 5, 6, 7. Yes. I do think this is correct. Yes, I do. Okay. Let's submit it and see. Sitting in queue. Let's go. Come on. We're just sitting here waiting. Wrong answer. Wrong answer. Chosen subsequence must be non-increasing. Bro. What exactly does that mean? Like, it has to be ones first and then zeros? So do they have to be in order or not? Like, I can just choose this one, this one, and this 0? Or what? No, I'd have to choose all 4. Let me think. Why don't I move this over here? Go back. Chosen substring must be non-increasing. So I guess that is what it means, like, you select the ones you want and it doesn't necessarily have to be in order. So this is chalked. This is also chalked. We need some like to print array. Like print len to print and then print star to print. This is not right anymore. I need to think about how to redo this. Hmm. Hmm. One oh 101. We want we basically choose ones first and then we choose zeros. So what we do is for I in range where the last zero is. String. Is there like a okay, it's a string, So I can use index of. I can dot index, but okay. That will give me the first instance of string. Okay, hold on. Okay, we can use this method. How do I use this? Simply just s.find. Although I think find and index does the same thing. The cool thing about find is there's this rfind, which is just should just be find reversed, right? Yeah, highest index. Because find finds the lowest index. So +1. So we're just looking for 1. And then to print dot append I +1. If si equals 1, append the index, and then we copy this. Is rfind. Then we change this to 0. And we already did this part. Uh-oh. Oh yeah, because I coded this. Or I copied and pasted this. But okay. So okay, the reason why this question is taking so long is not because I don't know how to code it or don't know how to think for it. It's literally the wording of the question. It's terrible. I don't understand what's allowed or not allowed. Wrong answer still. God damn it. Indices must be strictly increasing. They are though. It's 1. Test case 9. 1, 2. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this case, what's happening? Two, 1, 3. It is though. Am I looking at the right test case? I failed a lot sooner this time. Oh, I'm not even looking at the right test case. Jury's answer. Participants answer. Wait, am I? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's just take the first 15. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wait, I didn't even need that one. I needed this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Bob, Alice. Bob, Alice. What case is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's Alice. 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. This case. Choose 1, 2. 1. Yes, that works. I chose 2, 1, 3. Wait, he chose 1, 2. Wait, how does 1, 2 work? One, 3, 1, 2. Huh? I kinda hate this. Am I just misunderstanding the logic of how the indices work? 0, 0, 1, 0, 1, 1, 0, 1. 0, 0, 1, 1. Oh, 0, 0, 0, 0, 1, 1, 1, 1. Then we reverse these. What is my code doing? Find the last one, or find the first one. Wait, shouldn't these be flipped? So it should be find 1 or find 0? We want to collect all 1s before the last 0, and collect all 0s before the first 1. But these would obviously fail because okay, let's double check this. Bob, Alice, 2, 1. Sorted is 0, 1. No, this doesn't work. Well, we basically only need let me think. We only really need to select case 10101. Sorted is 1 going this. So we only going to select this one with this index. So what about 1, 0, wait, hold on, 1, 0, 1, 0, 1, 0, 0. This is decreasing, right? There's 1100. Flip it to 0011. Okay, so wait. So this is much easier than what I was doing. Just for I in range in if Si is not equal to sorted Si to print dot append I plus 1, right? We basically, the sorting like guarantees it's ones in front and zeros in the back, and then we just append the differences. Well, this one passed. This one, just need to double check. Yeah. Okay. Let's see if this works. So I'm gonna bookmark this for sure. It's green. Accepted. Alright. How long has it been? An hour and a half. Did 2 questions today. If y'all enjoyed this video, be sure to like and subscribe. I'll see y'all guys tomorrow. So this question absolutely cooked me. Alright.